topic of today's TechSnack is custom node packages. So my name is Maria, and I'm here to share my experience in creating custom node packages. During the talk, I will show how to create a simple package, test it locally, and publish to NPM registry. Also, we'll dive into related topics, like we will discuss package.json file properties, dependencies types, and semantic versioning. So let's kick off. Sorry, could you please return to the previous slide? Yeah, so let's discuss reasons why we might need to create a custom package. Developers publish packages on NPM to share their code with others, and organizations also use NPM to share code internally. For example, it may be necessary to share corporate design or data models between all applications. So let's get started with the first part of our talk. It's creating a package. And the first thing you need to do before creating your package is to choose a name. This is important because your package needs to have a unique name. And to ensure the name you've chosen is unique, visit the NPM registry and run a search. Be sure there is no exact match to the name you choose or a match that is too similar. As you can see from the second slide on the slide, NPM package written in one word is considered same as NPM package written with hyphen. And in case there is already a package in the NPM registry with the name you want to use, you have two options. You can choose a different name or publish your package as a scoped package. We will cover scoped packages a bit later. On next slide, you can see a screenshot from NPM registry search. Here we can see that, let's say I want to create a simple package like numbers randomizer, and we can see that randomizer name exists already, so we will need to publish a scoped package or choose another name. I will go with the scoped package option, so let's proceed with creating a package for now. To create a new package, next slide. To create a new package, we need to go with the following steps. Install Node if you don't have Node installed already. Initialize a Git repository if you need Git. We will miss the steps on the talk today as we want to focus on creating custom packages. Then we need to initialize NPM in a project via NPM init command and add your code. Initializing NPM via NPM init command will create a package.json file. You can see it on the slide. So now everything is selected because we have some technical issues, but I will just mention all properties one by one and describe their meanings. So first one is name, and it is exactly what you would expect. It's just the name of the model that package.json is describing. Next property is version. It is the current version of the model. We will discuss the meaning of those numbers in the end of the talk. The description property contains a human-readable description of the model, and it's developers' chance to let users know what a model does. Main property is a direction to the entry point of your model. So script section contains script commands which we can run, and for example, now we can see test command, and if we run npm run test, it will do exactly what's said in it, show message about no test specified, and exit. So let's add one more command as an example. It will be on the next slide. So here we've added start command, and now when we type npm run start in CLI, we will launch our project. Okay, in author property, you can give some information about author, and the license properties, the latest one, specifies the license for your package, which provides information on how people are permitted to use your package and any restrictions that you're placing on it. We've already had a great talk by Victor with more information about licenses titled How to Pick a Product Library, and if you want, you can find it on our previous talks. And now let's install some dependencies to see other important properties of package.json. We will install one dependency for production and another one for development only. Regular installation is performed via npm install. We're installing Ladash here, and When we install dependencies for development only, we need to add save dev flag. So here's example, we installing ESLint as example of dev dependency. So in package.json, we can see that two properties were added after installation, dependencies and dev dependencies. But what's the difference between them? Dependencies contains libraries which your project requires for production environments and functioning effectively. It consists of all the packages that are used in the project with their version numbers. You require these packages to test and run your project. You can add dependencies to the package.json file by running npm install and listing dependencies. There can be a lot of them separated by space. devDependencies property consists of all the packages that are used in the project in its development phase only, and not in the production or testing environment. Examples can be Babel or ESLint. Sorry, still previous slide. These types of dependencies are required during the development process, but not while testing or executing it. And to add devDependencies to a project, you just need to run npm install with save dev flag or its short version, capital D. But why do we need devDependencies if we can store everything in regular dependencies? Well, moving all dependencies to regular dependencies can increase your production bundle size. Also, separating dependencies into dependencies and devDependencies makes your package.json file more explicit. It clearly shows which packages are essential for running your application and which ones are development tools or testing utilities. On the next slide, we will consider peerDependencies and optional dependencies. Here's also some technical issue with presentation, so part of text is not visible. I will just describe it with words. So we have peerDependencies and optional dependencies. When dependency is listed in a package as a peerDependency, it is not automatically installed. Instead, the code that includes this package must include this dependency as its dependency. And when we use peerDependency, it's like we're saying, if you want to use my package, please install dependencies listed in peerDependencies also. So on this slide, you can see like diagram describing this. We have package A with the peerDependency package B. Package B is not used by package A and will not be installed when we run npm install in package A. Instead, it has to be added to package which uses package A with the same version specified. If package C uses package A, it has to install package B, as it's mentioned in peerDependencies of package A, and it should be installed with the same version. As an example, React and React don't specify each other as peerDependencies, and this allows developers to use different versions of React DOM with a related version of React. And there is no command to install peerDependency. You need to manually modify your package.json file in order to add a peerDependency. And the last type is covered by the image, but yeah, I will just tell about it. It's optional dependencies, and these are dependencies that are not necessarily required to be installed. NPM will automatically install all packages listed as optional dependencies, but if they fail to install, NPM will still say that the installation process was successful. Application will function as expected, whether the dependencies are present or not. It's your code responsibility to handle the lack of the dependency, and running npm install with omit optional flag will prevent optional dependencies from being installed. So let's go to the next slide. Every dependency may have its own dependencies, and the tree with all the versions is stored in package.json file. That's how it looks like, and this file is not published to NPM registry. So if internal dependencies were updated with some bug or incompatibility, the package may crash when someone else tries to install our package. So good news that we have a tool to avoid this. It's on the next slide, and it's npm shrink wrap JSON. It is a file with the same content as package.json, and it is used to log the dependency version in a project. After installing packages and updating your Node models folder, you should run npm shrink wrap command to create this file. npm shrink wrap JSON is publishable and will then take priority over any other existing or future package block files. So now we can add some code to our package. Let's go to the next slide. We create a random function here. So the create random function and just return the value of loaders library main function. If you're not familiar with require model expert syntax, here's a quick explanation on the right side picture. The entire code written inside the model is private to the model unless exported. Everything we add to model exports will be imported via require. We can export objects, functions, or any variables, and in our case, we export random function. So when we require X module from model Y, the require function will return what we have in model exports of model X. So hope everything is clear here. So let's proceed. Often we will need to update or change some NPM packages that we develop. Let's say we've tested locally our NPM package, so next we want to test how our package works from external project. Let's move on and see how to test custom NPM packages while developing. An intuitive approach is just publish the change to NPM registry, then update it in your project where you can install and test it. It may not be a good idea as it's a lengthy process and it's really time inefficient. On top of that, this left your package with unsuccessful versioning that doesn't mean anything, as you can't publish same version twice. So you have to publish or to update versions each time you are published. Obviously, you only want to publish versions to NPM registry when you're confident about the change you made. So what are the alternatives? On the next slide, we can see another option. It would be to install our package using absolute path. In this case, package.json dependency will look like on the screenshot. And now, using absolute path to develop local modules is really not a good solution. Also, we currently have a path in the code base that won't work for anyone else but us. We don't want to be changing the required path back and forth every time you go through a develop and publish cycle. So instead, we can use NPM link. Let's switch the slide, and with the following approach, you don't even need to reinstall your package for testing. First, you should run the npm link command from the root of your package project. This will make your package available globally, and you can require the package in a different project to test it out. To add the package you've created to your test project, run the npm link command with your package name. This will create a node models folder, and it will add all the files and folders from your package. You can now require your package and use it for testing. Let's switch to the next one. And now that said, npm link is not ideal. It may cause errors if your environment has multiple Node.js versions. Both npm link commands must be run using the same version. Also, when npm link can find package as global package, it installs it globally from the npm registry. It only fails when the package is also not found on the remote registry. When linking multiple packages, previously linked packages are removed. To link multiple packages, you must pass all package paths into one command. So what can we do is to use npx link, which is probably your best bet now. Let's see how to use npx link. Yeah, so it's safer and more predictable alternative to npm link. You can use it via the command npx link with package path specified. And npx link doesn't install linked package globally. It doesn't remove previous links, and it works across different versions of Node.js because it makes direct syntax and it also has a clear fail state when it can't resolve the package path. Let's see the structure after running a PixLink on the next slide. So on the left, we can see that we have a randomizer folder with our model and test folder for testing it. Inside node modules of test package, you can see your package installed. So that's what happened after PixLink. And on the top right picture, you can see the code inside index.js of our test project, just requiring the model and calling this function. And below, you can see the result of running PixLink and launching the test project several times. So as we can see, everything's working. Let's switch to the next slide. And yeah, here's our next topic. After testing your package and ensuring it works as expected, you can now publish it to the NPM registry. It's the last section of our talk, and here we'll explore scope packages and semantic versioning also. To publish your package on the NPM registry, you need to have an account. After creating the account, you need to run npm login command in your terminal. You will get a prompt to enter your username and password. You can now run npm publish command to publish your package on the NPM registry. You can visit the NPM website and run a search for your package. You should see your package show up in the search results, but let's firstly see what's the difference for scope packages. If an existing package has the same name you would like to use, like in our case, the workaround is to publish a scope package, or if you want to make a private package. To create a scope package, when init your project, you should pass the scope attribute with your username. For your package name, the format should be like you can see on the slide, with your username / package name. If you already initialized your project earlier, you can just change the name manually, and yeah, the name is the only difference for NPM, so you can do it by yourself. Okay, you can now add the code for your package and test it, and the process is the same as already explained earlier. Then to publish your scope package, run npm publish with access attribute in your terminal. And when you publish a scope package, you have the option to make it public or private. The value is private by default, so if you need public, you have to specify it. If it's private, which is not a free option, you can choose who you want to share the package with. So now let's see a screenshot. We can open NPM site and find our package here. Let's proceed with semantic versioning. Here is one more small and important topic on the next slide. We often create numbers like 1.0.0 or something like this for releases and hotfixes. And these numbers represent the version number of the product we put out in the world. We use them because we are following a best practice called semantic versioning. And when we use semantic versioning, developers will know whether a change will break their code. Numbers give a clue to the kind of changes that have occurred. And semantic versioning has 3 numbers. As you can see on the screenshot, the rightmost number is a patch version. Patch versions are used for bug fixes. There are no functionality changes. Second number is called minor version. It is used when you release new functionality in your project. And the leftmost number is major version. When you increase the major version, you tell people that there are backward incompatible changes. People may experience breakage if they use the next version. If you want to create a pre-release like an alpha or beta version, you can add a hyphen followed by words alpha or beta. And there are no hard and fast rules for pre-releases, so you can name them anything you want. Let's switch to the next slide. Most people start projects with 0.1.0 version. And when you're ready to release the project to the public, you increase version to 1.0.0. So to the next topic in semantic versioning, probably you've seen caret and tilde symbols before versions numbers in package.json file. This is a special syntax using which you can specify which versions of the package you want to use. Take a glance at the table. As you can see from it, tilde allows for patch updates, while caret allows for both minor and patch updates. Okay, hope everything is clear here. So that's the end of today's TechSnack. Thanks everyone, and in case you have some questions regarding these topics, you can write to the comments and I will answer a bit later. Okay, so if you have any questions or want to be a speaker, you can reach anyone from the list here. And yeah, we're always looking for speakers. Thanks everyone.